Now we're on to inscribed angles, and an inscribed angle is an angle whose vertex is on the circle and whose sides are chords the circle. So for example, here we've got a chord and another chord. Let's call it chord AB and then BC. So the inscribed angle is this guy, the angle made those sides of the chord. So angle B is our inscribed angle. And we're also going to use other language. We're going to talk about the intercepted arc. So the intercepted arc is the arc. This guy. Intercepted arc. Oof, that handwriting. So that's the arc that's basically kind of cut off by those two chords. So we've got our inscribed angle and intercepted arc. Our first theorem deals with both. The measure of our inscribed angle is going to be half of its intercepted arc. So if I look at angle B right here, the measure of angle B is going to be half the intercepted arc. And the arc that it intercepts, if I follow my chords, the arc that is being intercepted is this guy right here. So the measure of angle B is going to be half arc AC. So if we've got a value of 1, we can find the other. So let's look at our first one. Find the missing value. So we are missing the measure of angle A. So we're saying that the angle is equal to half the arc. That's all we're saying up here in just simpler terms. So I don't know the angle, so I'm going to say angle A is equal to half whatever the arc is. And it looks like if I follow the chords that make up angle A, it goes AC, AB, and I notice that the arc that they're cutting off is arc BC, so it's going to be half of arc BC, which is 80. So then I know the measure of angle A is going to be half of 80, which will be 40. Again, we're looking at arc versus inscribed angle. This time I don't know the arc. So it's still the same idea. The angle X this time, because right, it goes, arc is being cut off. If I look at W and V right here, WX is a chord, VX is a chord. So the angle we're going to look at is 42. So the measure of angle X is going to be half the arc. This time we don't know the arc, but we do know the measure of our angle, so we fill in what we know. We know it's 42 equals half our arc. So I can multiply by 2 on both sides, or I can know, I think multiplying by 2, and then we'll get that the arc is 84 degrees. So you just fill in either the angle or the arc, either you're multiplying by 2 or dividing by 2 to get what you're looking for. And we'll do C and D. Again, we've got angle equals half the arc. So I'm looking out, I'm missing arc, DC. What is DC, the arc related to? It's related to the inscribed angle B. So I know that do I know this angle? No, but I am working in a triangle, right? And I've got 2 out of the 3, so I can actually find the measure of that third angle because the sum of the angles in a triangle is 180. So we'll do 180 minus 49 minus 70, and we'll get this angle 61 degrees. So the angle is 61 degrees, and that'll be half whatever my arc is. So to solve, I'm going to multiply by 2, and I'll get that the arc is 122. So I can also label it as arc DC. The measure of arc DC is 122 degrees. The last one has a couple things we need. We need both A and B. So I want to connect A, arc, that 1 PT, arc PT, with the inscribed angle. So the intercepted arc PT comes from, and I follow that line and that line. So it looks like it's related to angle PQT. So angle equals half the arc. So the angle is 60. So the arc is 120. So that's 120. Then for B, and that tells me that that's what A is. So then for B, I'm looking for the intercepted arc versus inscribed angle. So B is the angle made up of RS, chord RS, and RP. And if I look, the intercepted arc includes PT and then also S. So the whole thing, this whole arc is going to be 150. And again, the angle is always half the arc. So the arc is 150. So I need half the arc, half of 150, to give me angle B, or the measure of angle R, which is B. And I get 75 degrees. So we've got A and we've got B.